is this?
1C.
1C, page 261. Okay, question says P? No. 500 is equal to N subscript 0. Okay.
1, 2, 5.
All they're taught, they just want you to solve for N. So think of N subscript 0 as
1, 2, 5. 1.5.
Think of that, N subscript 0, think of this as just a variable.
Okay.
So it's like X. I could replace the entire equation with 500 is equal to X times 1.25 to the power of 1.25. Okay, this is just straight algebra. So I'm going to simplify this number here, 1.25 to the power of 1.25. So yeah, that's 1.25 to the power of 1.25.
1.3.
That's what you got?
Yeah.
1.3217. Okay. So 500 equals 1.3217. Okay, that's good enough. Okay, because that says multiply by x, we're just going to divide both sides. All this is solving for x.
Okay.
By 1.3217.
That's not hard.
Yeah, it's pretty straightforward. 500 by 1. 7 equals. That's it. It's just solving for n. That's all that question was.
Okay. You make it look so much more.
Yeah, it looks confusing at first. They really could have just replaced n0 as our x.
Yeah.
Okay, so when they're talking about exponential growth and decay, they use f at x as your final answer, and your skeleton model, or like your theoretical model, they have A, B, and X. Okay? A represents the initial amount of something. Initial amount. And we'll do an example. B represents your growth or decay rate, I believe is the term they use, right? What do they call it here?
Yeah, growth rate.
Yeah. And they just say B plus growth rate is for growth. Yeah. And X is the number of periods it goes over. So X is number of periods. So for instance, let's say I have $1 million because I am so rich. Okay. So I have $1 million in the bank. I don't know why I'm using such a ridiculous number. So I got $1 million. So because I have $1 million, that's my initial rate. Okay. That's my A, my initial amount. And let's say I put it in, I invested in a friend, and all he does is spend money. So his decay rate, actually, let's do growth now. Let's say he puts it in the bank, and the bank earns 0.03 or 3%. Okay? Mm-hmm. So it earns 3%. So it's got a growth rate of, your growth rate is 0.03. So you take that 3%, you turn it into a decimal. But it doesn't mean that B is 0.03. You actually have to add it to 1 because it's a growth rate. Okay. Anything less than 1 is going to bring down the initial amount. So this would actually say I'd have less money, but if I've invested it, I should have more. So your actual growth rate, you have to add to it. It's 1 plus 0.03. Okay? So 1 plus, let's get a little note here. B for growth is 1 plus that growth rate. We'll call it G rate, okay? Mm-hmm. And B when it's decay, usually this is done with like scientific models and stuff. They really use it. Technically there's other formulas for money, but this is just an example, okay? It's 1 subtracts your decay rate. So if your decay rate was 0.03, you'd subtract that from 1. Okay? And let's say I invest, this is a really bad example, but let's say I invest for 5 periods, okay? So let's say it happens every year, and I keep it in for 5 years. That's the idea behind this. Now, technically, this isn't the right math formula for it, but all we got to do is simplify. So f at x is $1 million 1.03 to the power of 5. So let's get our calculator. 1.03 power of 5 equals 1. Write that down. Oh, I lost it already. Do you know what that said?
1.15.
1.15. Let's just double check. 1.5. Yeah, that's good enough. We'll just round it for now. And then I take that number. This is going to give us an exact times 1 million. So, because I invested in my friend, oh, I'm rich. I get 1,159,274 and 7 cents. So, after 5 years of investing, I got $1,159,000, 274 and 7 cents. Okay, so that's the idea behind growth. Okay, so you just add the growth rate to 1 if it's a growth rate. If it's a decay, you subtract from 1. But that's the big part. So if they give you any word problems, initial value is always your A.
How do you know if it's a growth or decay?
Usually in the question it'll let you know. For you to say, let's say they give you an actual like equation. Is that what you mean?
They give you an equation here, and they're like, is it growth or decay?
Ah, okay, good question. So let's make one up. F at x, 75. Ready?
Mm-hmm.
This is the number they give us. To the power of 6. Is this growth or decay? First of all, which variable do I have to look at? Am I looking at B, A, or X?
B.
Yeah, that's right. So I really don't even need to write the rest of this. A, X. Let's just put it up there. You're right. We are looking at B. So that's what's important. We look at the B. So pretty much to tell if it is growth or decay, is B greater than 1 or is B less than 1? In this case, it's less than. So if B is less than 1, we're talking about decay. Because in the end, your initial value, if this is less than 1, is going to be lower. And if it's greater than 1, you're talking about growth. Okay? Because your growth rate's always added to 1.
Yeah.
And your decay rate's always subtracted from 1. And if it is 1, it's not going to change. It doesn't matter how many periods it's going to go over. Because 1 to the exponent of anything is still 1. So your initial value will actually end up staying the same.
Okay.
Does that make sense?
Yep. Okay.
Okay. So because growth rate is always added or subtracted by 1, assume 1 is the starting point. Anything added to 1 is considered your growth rate or taken from 1. Oops, wrong page. So let's go back up here. So for instance, this one, our growth rate here, our B was 102. So in that case, I take 102 and subtract 1. 0.02 is what, oh, I forgot I can't draw zeros with that. 0.02 is what's left over. So I took 1.02, subtracted by the 1, because the 1 is what we always start with. So we're trying to figure out what was added to the 1, 0.02. We knew it was growth because it was greater than 1, right? And initial value, our A was 20. Does that make sense?
Yeah.
Okay. Initial value here. There's no number.
Yeah.
But you assume it's a 1, not a 0. If it's a 0, do you know what's going to happen?
It would multiply to equal 0.
Yeah, it'll always end up being 0. Our answer won't be that in this case. Because it's less than 1, it's a decay rate. Okay?
Yeah, I got that.
All right. Now, because it's decay, think of it like this. Start with 1 and subtract by whatever the value of B is now. So 1 subtract 0.8 is also, oh, I wrote that wrong. It's 0.2. Okay, 1 subtract 0.8.
Okay, I got that.
And the reason for that is because think of it like this. If I took 0.8 subtract 1, you're right, I'll get negative 0.2. If I were to turn that into a decay formula, remember our decay formula is 1 subtract what the decay rate is. If my decay rate is negative 0.2, it ends up becoming 1 plus 0.2, which makes it a growth rate, which doesn't make sense because we're dealing with a decay rate. So when you have your decay rate, think of it like we always take the initial value, our 1, and then subtract by whatever's in there. When we have growth rate, take whatever's in there and then subtract by 1 in order to find growth and decay. So this was to find, decay, and this is to find growth. Does that make sense? You want me to do another one?
I get it now.
Yeah, you get it?
Yeah.
Okay, so what about the third one? Your initial value is 0.3. What would your growth rate be?
That was wrong.
See where I can hide things. Yeah, it's all hidden.
2. Because you subtract the 3 from 1.
Yeah, exactly. Wow, I was hoping to like hide this and bring it over. This is so slow. And what about the last one? Was it decay or growth?
Okay, it's decay.
Because it's
less than 0. I mean, less than 1.
Yeah, less than 1. Hi, girls.
And then, so the initial value is 600.
Mm-hmm.
But then, so you subtract 1 from that.
Yep, to find the decay rate.
Yeah, but 5 divided by 8 is 0.625. Well, like, you put it in a decimal, right?
Okay, and let's see what that is. I did it as a fraction, so I just turned 1 into 8 over 8. So it became 8 over 8, subtract 5 over 8.
Oh, okay.
So it becomes 3 over 8 Swiss over. Let's do 3 divided by 8.
Yeah, that's a lot easier. Equals
0.375. Is that what you got in the other one?
No,
I
didn't.
Round it.
Like, okay, so 1 subtract, what was it? 5 divided by 8. And then 1.
So, last question says population is 2,000 people.
Yeah.
How long is it going to take?
Yeah.
So you're right. You substitute 2,000 in for P at n. So this equation now says 2,000 is equal to 1,050.03 n. Okay. Think of this when you're solving for a variable as reverse bed mass. So normally you deal with exponent and brackets.
Yeah.
We're going to deal with actually
Multiplying it first?
Yeah, well we're going to actually move that. I want to get n by itself, right? So I'm going to move this 1,250 times this. I'm going to divide this side of the equation by that, which will make these two cancel out. And then divide this side of the equation by that. Okay. That's going to give us 2,000 divided by 1,250. 1.6. That's a nice round. So we got 1.6 is equal to 1.03n. Now she hasn't taught you logs or anything like this. So what you need to do is you need to figure out this number to what exponent is going to create this number.
Okay.
Okay, so you kind of have to break it down. So this is where you kind of do a trial and error. 1, you can try to the exponent of 2, 3, 4. You'll start to get a good idea when you're jumping through. So, for instance, the very first one, I'll try 1.03. Let's go squared is 1.06. That's barely anywhere. So I'm going to jump right ahead. This became 1.06. I'm going to jump ahead to 5. 1.03 to the 5th. 1.5. I still got a bit to go. Just jump right up to 10.
I did 9. It was 1.3.
9 was 1.3?
Yeah.
Alright, forget 10. Let's go to 20. 1.03.
1.8.
Alright, too high. Let's try 15. This is the trial and error method, right?
Got it.
Is that it?
15 is 1.55.
Okay, let's try 16. 16. Hey, that one's closer.
Okay.
Yeah, that one's close. Yeah. So it's going to take approximately 16 years, okay?
Okay.
So that's kind of the trial and error method. You will eventually learn how to reverse.
So that's how she wants me to answer it now?
I would assume so. Let me just quickly take a look back in your book.
So then how do you just write it?